8.2 areas in the plane. So we finally are to area between curves. Any guess how we're going to solve for area between curves?
With an integral?
Good guess. If f and g are continuous with f of x greater than or equal to g of x throughout the interval a to b, then the area between the curves y equals f of x and y equals g of x from a to b is the integral of f minus g from a to b. And so we would have the integral a is equal to the integral from a to b of f of x minus g of x dx.
Is that all of them?
What's written in red is the big thing you need to know. Like, that's the formula for finding area, so. All right, so area can, like, between curves can be looked at a few different ways. You could have, like, these two curves like this, and you're finding the area between them, and then the a to b are the parameters that it's on. There's other ways we can do it with, like, rectangles and approximating the area that way. You might also have curves that are, like, inverted like that, and you're looking for the area in here. You might have two parabolas and then some, like, lines and stuff, and then, like, you're filling in, like, this area here that's, like, not in the parabola. It's, like, everything outside of it. Area of an enclosed region, a parabola and a line, and find the area between here. So there's all different, like, ways that this can look that we'll be solving for. You might want your books open just because they give you pictures for the first problems to help you visualize what's happening, so just might be good to have it. It's page 399. It says to find the area of the shaded region analytically. Now, if they didn't give you the graph, then they would have to give you the two functions, and then you would graph them. The one that is, like, the most above is f of x. The one that's below is g of x when you're finding area. So, number 2, look look at it first and then I'll. So this is graph number 2 over here. So we've got this top shape here is 1/2 secant squared of t. This bottom one is -4 sine squared of t. So the one on the top is going to be my f of x. The one on the bottom is going to be my g of x. Because when I do it, it's going to be the top minus the bottom to get that area in between there. So I'm going to write it like this as f of x equals y equals 1/2 secant squared of t. And I'm just doing that because of the way that they have them written as y's, but I'm going to go ahead and label f of x and g of x so that way we have it from the formula. And then g of x is equal to y is equal to -4 sine squared of t. Now, the other thing that I didn't point out, so let me put this back under here for a second, is that the a to b values are the right and left bounds of this. So you can see this is like a pink line here. So this is going to be from -pi/3 to pi/3. So I usually will go ahead and write that as well. It's just like the parameters that we put on our integral from a to b. So it's just our interval. So from -pi/3 to pi/3. So now area equals the integral from -pi/3 to pi/3 of 1/2 secant squared of t minus, but notice since this is negative, it's going to be plus 4 sine squared of t dt. Now, when I have an integral of two things being added together, what can I do? I can break them apart. So we can do that, or if you feel comfortable just doing it all as one thing and not breaking it apart, that's also fine. I don't care, but just wanted to review that fact. So do y'all want me to break them apart, or you just want to do them all as one thing?
Yeah.
Okay. So this will be the integral from -pi/3 to pi/3 of, now since this 1/2, since I am going to break it apart, I'm going to pull the 1/2 out front. So it'll be 1/2 secant squared of t plus, I'm going to do the same thing with this 4. So 4 integral from -pi/3 to pi/3 of sine squared of t. And both of these should have little dt's on them since I split them. What does the first one give me? So this is going to be 1/2 tangent of t from -pi/3 to pi/3. Any idea about the second one?
Negative cosine squared.
No, because when I take the derivative of that, I would
Yeah,
get
it wouldn't be.
sines. Yeah.
So I don't know.
I think this is one that's in one of the tables in the back. So let me look, because if not, we just have to use the calculator, because y'all know.
At least it wasn't. It makes me feel better. See, that's that. I was like, that's not gonna work, but
Okay, there's the cosine one. Where's the sine one? Okay. Yeah. Okay. This is in the back. Let me show you where these are really fast. In the back of your book, you have an appendix that looks like this. And it's a brief table of integrals. And by brief, I mean it has like 150 in it.
yeah.
Okay? These are integrals that some of them, like, you kind of should just know. Like, some of them, like, we've gone over before. Like, you know, sine of u du. So this is just some of them. But then there's some, I'm scared this is going to go off, that you don't necessarily just know. And so that would be the one that we just are looking at here. So the sine squared of ax dx is x over 2 minus the sine of 2ax. Now we don't have an a in our situation, so we would just it'll just be 1 over 4 times a, and then plus c, because this is doesn't have dimensions on it. Okay, so this one, if they gave it to you on your AP exam, because like it is solvable obviously, but you don't know how to do it. So, this one they would have to it would have to be a calculator problem for you to be able to.
Okay, so they don't
to
want
do
to say we don't have to memorize like all that.
No, I mean, I will tell you, like, the sine and cosine one of this is pretty much identical, other than sine is positive for cosine and it's going to be negative for sine. Like, so, I mean, there are a few of those, like, might be good to look over in the back. But, like, no, I don't, you don't need to know all of these. I mean, like, that's just excessive. Like, in theory, these should be given to you. Like, you know what I mean? Or you should have a calculator to do them. Yeah. So this is going to be plus 4 times x over 2. Let's see, I do it this way. X over 2 minus sine of, or I guess this is supposed to be t because we're in t's, aren't we? So t over 2 minus sine of t over 4. And if there was a number in front of t, that would just also be in here with this, like that. And that's evaluated from negative pi over 3 to pi over 3 as well. So, I'm going to do 1/2 times, what is the tangent of pi over 3?
Root 3 over 3. Or is it just root 3? It's just root 3.
Because opposite
Because
sine opposite.
6 is root 3 over 3, like pi over 6.
3 over 2.
But I did that because there's 2 3. The only reason I know that's because there's 2 3, so I just thought, oh, that's
This one's just root 3.
yeah.
Right? Is that what y'all are saying it is?
Yeah.
Yeah, okay. That's what I was like. At first I thought y'all were trying to say it was root 3 over 3, so I was like,
No.
I don't think so, but let
No,
me
I was
check.
trying to explain why root 3 over 3 is 6. Well, like, not that equals 6, but, you know.
Yeah. Okay, so root 3 minus, when I plug in negative pi over 3, what do I get?
Negative.
Negative root 3, so this is going to become plus root 3 plus 4 times, these ones are going to get a little dicey. So I'm plugging in pi over 3 for t. So pi over 3, it might be better just to look at it like this. So pi over 3, since I'm dividing by 2, that's times 1/2, minus, what is the sine of pi over 3?
Root 3 over 2.
Root 3 over 2. So root 3 over 2, again, times, since it's divided by 4, times 1/4. Let's do this. Minus negative pi over 3 times 1/2 minus, what's the sign of negative pi over 3? Negative root 3 over 2, so plus root 3 over 2 times 1/4. Are y'all tracking why I did the times 1/4 and the times 1/2?
Yeah.
Okay. So now, over here, this is going to be 2 root 3 times 1/2, so that's just going to be root 3. Plus 4 times, this is crazy, pi over 6 minus root 3 over 8. And then plus pi over 6 minus root 3 over 8. So then that's going to become 2 pi over 6 minus 2 root 3 over 8. I don't know how far they want us to go with this. Are we just finding the number, like a decimal number? Okay. So then I'm gonna take a get a common denominator. That's what I'm gonna do. I just can't decide which way I want to do it. I'm like, there's pros and cons to both, so that would be 2 pi. Just kidding. I'm going to multiply through first. Sorry, stuff's going to cancel. That's why I'm like, wait a minute. Okay, so this is just distribute first. So 8 pi over 6. I know it's going to reduce, don't worry. Minus 8 root 3 over 8. It'll just make your life easier to do it this way. So then I can simplify. 8 and 8 go away. Over here, 6 and 8, that becomes 3, that becomes 4. So now I've got root 3 plus 4 pi over 3 minus root 3, which ends with 4 pi over 3. See, at that point, it just becomes the algebra part that you just gotta, like, process which way to do it. Well, I was looking at it and then I was like, wait a minute, this is going to cancel, I feel like. So then I, like, looked at it, and that's why I was, like, processing in my head which way I wanted to do it.
Like, when I already gotten 4 pi over 3 before you went to that part, I thought I was wrong. I went an entirely different way.
So
Alright.
that's the area of
Yes, between the two curves.
does it need, wait,
No, it does not. All right, so 4 is a little different in its setup because it's got curves that are like sideways. Okay, so the right curve is going to be my positive one because it's in the positive direction. The left one is going to be my negative one, so it's going to be g of x.
So the left is G of X?
Yes, because that's going to be like the negative direction. And technically, it's kind of like, if you notice, it's actually between those, like, so it's a little lower, so that's also part of it there. So we'll just set this one up because the bell's going to ring. So f of x is equal to y wait a minute, I lied. F of y, because these are y's in this problem, is equal to x is equal to 12y squared minus 12y cubed. These are going to work the same way as the other ones, just the variables are different because of the direction the graph is going. And then g of y is equal to x is equal to 2y squared minus 2y. And the parameters on this one go up and down because the graphs are sideways, so it's from 0 to 1 was the parameters on this one. So then our integral is going to be from 0 to 1 of 12y squared minus 12y cubed minus 2y squared minus 2y dy. And with this one, rather than breaking it up, I would actually just combine like terms. So like I would get to the integral from 0 to 1 of, let's see, negative 12y cubed, 12y squared minus 2y, so that's going to be 10y squared minus plus 2y dy, and do it that way. We actually might be able to finish it. What's the integral of this?
Like taking the negative 4, lots of 3, negative 3, lots
Yeah.
of 4.
Yeah. Because then when you, yeah. I always have to do them and then check them back to see if they're right, because I often will like do stuff like that and I'm like, oh wait. What's the next one? And the last one? Y squared, and all that's evaluated from 0 to 1. Obviously with the 0, everything's going away, so all I have to worry about in this one is the 1. So it's just going to be negative 3 plus 10 over 3 plus 1. And when you get a common denominator and all that, it ends up coming out to 4/3. So forgot that one was actually going to be fast because it didn't have trig values in it. It's a little faster to do. But we'll do a few more of these on Monday. We probably will be able to wrap it up on Monday, actually. Overall, and then, yeah. It'll be close. We may or may not be able to finish it, but we'll be close.